I am K. Department of Physics. Today my topic is Unit 2 Thermodynamics. Explain about the entropy change in a reversible process. So the reversible process heat engine working between two temperatures T1 and T2. So two temperatures T1 means source means a hot reservoir. So T2 means sink means cold reservoir. So reversible heat engine working between two temperatures T1 and T2 following the four steps or four process. First one, isothermal expansion. So this is the heat engine diagram. So taken on x direction value, y direction P. So this is the first point, pressure P1 and volume V1. So next pressure P2, volume V2. Next pressure P3, volume V3. Next one pressure P4, volume V4. So this curve is indicates the isothermal expansion. Next this curve indicates the adiabatic expansion. So this curve indicates the isothermal contraction or compression. Next this curve indicates the adiabatic contraction or compression. So this is the four steps, 1, 2, 3, 4. So four process. First process is isothermal expansion. Isothermal means, in this case, isothermal means temperature is constant. Remaining variables are changed. So P1 to P2, V1 to V2 changed. Temperature is constant. Temperature T1 equal to constant. So some amount of heat, some amount of heat. So some amount of heat Q1 absorbed in engine from source T1 Kelvin. So some amount of heat absorbed, some amount of heat Q1 absorbed in engine. This is the engine absorbed in engine from source T1 Kelvin. So T1 Kelvin source. Change in this case, change in entropy, entropy indicates the S. So first process means S1. S1 equal Q by T. So Q first process means Q1 by T1. So isothermal expansion, temperature is constant. Remaining variables are changed. So T1. So entropy means the ratio between the Q and T is called a entropy. So this is the equation number 1. This is the equation number 1. Next one. Next process 2. So next process 2. Number 2. So this curve, adiabatic expansion. Adiabatic expansion. So in this case, heat is constant. Heat is constant. That means entropy is 0. That means entropy is 0. Adiabatic process. Adiabatic means heat is constant, remaining variables are changed. So heat is constant, P2, remaining variables, pressure P2 to P3, volume V2 to V3 changed. So entropy formula of entropy S equal to Q by T. So heat is constant, heat means Q equal to 0, that means S equal to 0. So adiabatic expansion, the entropy is 0. Next process, isothermal contraction. Isothermal contraction. So isothermal contraction. In this case, temperature is constant. So isothermal means temperature is constant. Remaining variables are changed. So pressure P2, 3, P4, V3 to V4. Remaining variables are changed. So some amount of heat, that means Q2 rejects the heat engine, change in entropy, entropy S equal to Q by T. So entropy S2 Q2 T2. So this is the entropy, equation number 2. So isothermal means temperature is constant. So T1, T2. So temperature T2 constant. Remaining variables are changed. P3, P4, V3, V4. Remaining variables are changed. Next, fourth process. Next, fourth one, adiabatic contraction. In this case, heat is constant. Remaining variables are changed. So heat is constant. This is the adiabatic contraction. Heat is constant. Remaining variables are changed. P4 to P1, V4 to V1, temperature T2 to T1. Remaining variables are changed. So a change in entropy, 0 is 0. So change in entropy means S equal to Q by T. So this is the entropy. So heat is constant. Means 0 by T, that equals 0. So this case is 0. From equation number 1 and 2, from equation number 1 and 2, okay, total change in entropy, total change in entropy, S means entropy, ds means change in entropy. So change in entropy means S2 minus S1. So change in entropy. So from equation 1 and 2, ds equal equation 2, S2. S2 means Q2 by T2 minus S1 means Q1 by T1. This is the equation number 3. This is the equation number 3. Next, according to Kelvin scales, according to Kelvin scales definition, Kelvin scale definition. So according to Kelvin definition, Q1 by Q2 equal T1 by T2. So Kelvin scale definition means heat engine. And so this is the heat engine. Heat engine working between the two temperatures T1 and T2. That is the Kelvin scale definition. So heat engine working between the two temperatures T1 and T2. So this is this formula is the Kelvin scale definition. Next, next one. So cross multiplied Q1 by this side T1 cross multiplied. Next, Q2 by T2. From 3 substituted will be this value, equation number 3. This value substituted in equation number 3. ds equal Q2 by T2. Q2 by T2 means Q1 by T1 minus Q1 by T1, that equal to 0. So ds equal to 0. Therefore ds equal to 0. So entropy change in a reversible process constant. Therefore the entropy change in reversible process is constant. 0 means constant. This is the question and answer. Note that. Thank you, friends.